In the movie Kingsman, directed by Matthew Vaughn, there's a line. When the number of viruses becomes too many on a host body, either the host kills the virus or the virus kills the host. If you really think about it deeply, that's exactly where we are right now. See, life didn't begin on Earth in harmony. Earth was filled with lifeless matter, cold, empty, neutral. Then suddenly something foreign appeared, a microscopic living thing, something like a virus to the Earth. If you consider this planet as a host, harmless at first, because consider what a single living cell possibly could do, but life had one instinct to spread, to reproduce, to grow, to turn non living matter into itself. And over time, this quiet invader took over the oceans, the forests, the skies, everything. Life didn't hurt the earth back then. It was just small, manageable, but now things are different. We have grown too vast, too fast. Earth is reacting, but this isn't the end, only evolution. Life spreads, it adapts, now it must reach further. Space is not escape, it's expansion, insurance, continuation, and maybe redemption. We have multiplied, we are causing deadly wars, pollution. Earth, the host, is heating up, drowning, shaking, reacting, and now it's just like the quote said either the host destroys the virus or the virus destroys the host unless the virus finds a new place to live. So, how do we build that place? A place where we can thrive without destroying the host. Thus, we bring the answer. Stellar sanctuaries is our answer. We propose a sanctuary at Earth, Moon, Lagrange point 1. A gravitational sweet spot between Earth and the Sun, stable, solar rich, perfectly placed. The structure, a giant rotating cylinder, 8 km wide, 4 massive petal-like modules branching off it. Each petal runs a core system. Green palette runs food, water, waste, and life itself. This isn't just about survival. We are building an ecosystem, a place to live, to grow, to feel human space.
This is Green Palette, our agricultural petal, spanning over 1,011 acres. It feeds the entire settlement. Every inch is optimized for nutrient yield, with no soil wasted. Bioregenerative life support systems and controlled ecological life support system handle water, air, and waste, closing every loop, mimicking Earth balance. And thanks to our orbit at Lagrange point 1, it runs on endless sunlight. Our food system is rooted in space farming. Over 1,000 acres of vertical farms, hydroponics and aeroponics are used. No soil, minimal water. These crops are carefully chosen for their nutritional value and ability to thrive in controlled conditions. We grow leafy greens, pulses, berries, tomatoes, even dwarf fruit trees. Sunlight is simulated through full spectrum LEDs, and nutrients are calculated by AI in real time. And for protein, we rely on plant-based alternatives, fermented foods, and lab-grown dairy. This food isn't just for survival, it's for health, moral, and human spirit. Instead of astronaut mush, our habitat grows real balanced milk. This chart shows how we meet daily intake with leafy greens, berries, pulses, plant proteins, and lab-grown nutrition. Not just fully, properly nourished.
Don't need to dream of futuristic technologies. We use CRISPR technology to edit plants for faster growth and improved adaptation to space. We have engineered bananas and nut trees to grow compactly and bear fruit earlier. This makes sure we have our food available within months, not years. All of these technologies, CRISPR, plant engineering, are already being used on Earth. We simply need to scale them for the space. We used CRISPR-Cas9 to edit two key genes at SCL28 for faster growth and ARG1 for stress resistance. This graph shows how they boost yield, resilience, and efficiency.
Biotechnology enables personalized food. We ferment lactobacillus to make probiotic dairy products from plant milk. For meat alternatives, we use extrusion and 3D printing to create plant-based protein that mimics the texture of real meat. Robotic chefs programmed to prepare meals are connected to nutrient sensors. This ensures that every meal is fresh, balanced, and tailored to individual needs. Vertical farming maximizes space. Crops grow on stacked shelves with optimal lighting, moisture, and nutrients. This design uses zero soil and makes space uses 10 times more efficient than traditional farming. Light, temperature, and humidity are all controlled via AI, creating perfect growing conditions. No seasons, no pests, just consistent year-round food production. This one shows why we picked hydroponics and aeroponics. In just 30 days, they blow traditional soil yields out of orbit. More food, less space. Way faster. Exactly what our habitat needs.
Is another breakthrough. Roots are suspended in air and mixed with nutrient-rich water. The method saves up 96% of water used in traditional farming. It's perfect for high-protein crops like legumes as well as fruits like tomatoes and strawberries. Tested on the ISS, aeroponics offer fast growth and higher yields with fewer. Hydroponics uses nutrient-rich water to grow plants without soil. Systems like deep water cycle and nutrient film technique provide continuous growth and high yields. Lettuce, Spanish, beans, and roots vegetables all thrive in these systems, which are fully integrated into our habitats. Life support loop. This method is reliable and clean, perfect for the sterile environment of the space.
We treat waste as a resource. Organic waste is broken down by mycelium-based composters, which turn it into nutrient-rich compost. Inorganic waste is sorted by AI and recycled via plasma arc technology, turning metals and plastics into usable materials. We close the loop on waste, everything is repurposed. This bar chart shows that organic waste dominates at 60%, followed by inorganic waste and carbon dioxide emissions. It highlights the need for biological and chemical waste management strategies in closed habitats. This network graph illustrates the self-sustaining flow of resources between humans, crops, water, and air. It shows how waste, carbon dioxide, and water are recycled to maintain a regenerative life support system.
Water is precious resource in space. We cover up to 96% of water. Sweat, breath, urine all are filtered, purified, and reused. Reverse osmosis, outer filtration, and iodine disinfection ensure clean, safe water. In space, nothing is wasted. Every drop counts. Bioregenerative Life Support System or BLSS, a controlled ecological life support system or CELSS form the backbone of our habitat. Algae scrub CO2 and produce oxygen. Plants grow in recycled water and waste is composted. This is a living system where each component supports the others, creating a self-sustaining environment for the long term. This radar chart shows CELSS outperforming BLSS across most life support functions. CELSS excels in automation and energy while BLSS remains strong in air revitalization roles.
Energy is provided by solar arrays, with radioactive thermoelectric generators providing backup power. We see air is filtered and oxygenated by cyanobacteria, while temperature and humidity are regulated using pellet coolers and dehumidifiers. This ensures a stable, safe environment for all. The energy versus the output 24-hour cycle line graph illustrates the energy contribution of the green palette from solar, RTG, and battery powers compared to the total demand over 24-hour period, showing that solar peaks at midday while battery and RTG provides characteristic support with the total demand fluctuating throughout the cycle. Again, we see that why this is actually important, because this isn't based on future fantasy, it is grounded in technology we have today. Hydroponics, CRISPR, solar power, AI controlled kitchens, they all exist now. We have simply connected these technologies into a system that we cannot support life in space today, not tomorrow. We didn't invent new physics, we didn't wait for hypothetical breakthroughs. Everything we use, from oxygen producing algae to nutrient cycling systems to lab grown fruits, 3D printing and regenerative water loops already exist on Earth or in orbit. We see that our greenhouses uses vertical farming systems being tested in urban megacities. Our crops are edited with CRISPR just like in modern agriculture. Our energy systems are real. Our recycling system is operational. Our AI runs kitchen, which gives us food. We didn't build science fiction. We build science connected. We imagine a utopia. We engineered with a sustainable sanctuary. That is why we are different.
A space that breathes. A space that feels. A space that listens. A
A space that feels like home.